Hi everyone, I'm Jonathan Toga Sihotang.
I'm Agatha, Naquita, Aurelvia, Adena
From 3 State Senior High School, Semarang. On this occasion, we will present the result of our study project, TERBISA.
Software based on visual imaging as a two-way communication for the deaf and mute. Communication is an essential method used so that living things can connect and understand each other. However, in everyday life, we can easily find barriers to communication, most of which are caused by the non-functioning of the sense of the listener and speaker optimally, as found in the deaf and mute groups. In order to overcome this, a systematic cultural product was created in the form of sign language, which has special features in terms of language rules and vocabulary, so that it is fully accessible to the deaf and mute.
Nevertheless, the use of sign language, especially among the deaf and mute, has many limitations, which is caused by the low mastery of gesture by ordinary people. Communication between the deaf-mute and non-deaf-mute group is hampered. The limited translation of sign language into successful spoken language creates socio-cultural distance, which proves to be more effective in separating us. Meanwhile, other social problems also follow. Due to environmental conditions that increasingly reject the urgency of using sign language in the deaf-mute group, 90% of pre-language deaf people have parents with healthy hearings who usually have no experience or even tend to reject the use of sign language, so that the information and communication needs to deaf children cannot be met. In several countries, sign language was excluded from the deaf language education curriculum because the focus was set more on language articulation.
The purposes of this research is to know how to design TERBISA, to find out the flow or how the sign language visual image conversion system works into spoken language on TERBISA, to find out the effectiveness of using TERBISA, to find out the possibility of using TERBISA in everyday people's lives. Based on a literature study, it is known that there are some similar applications. However, they are known to be less helpful because some only provide education, meanwhile translating does not support gesture updates or only translate one variety of sign language. It also has many complexity that is not friendly for deaf speech users with poor understanding of spoken language. This research was conducted from December to February 2023 using the user-centered design methods. The programming language used is Python for making machine learning and Java for deploying applications, while the tools and materials we use are as follows. The stages of this research are literature, observation, system planning, implementation, and testing. The TERBISA application machine learning system is designed to work according to the following flowchart. The developed system is made using the Python 3 language installed on the Windows 11 OS. The system also uses the TensorFlow and MediaPipe libraries, which are installed independently. Here are some parts of the source code of the TERBISA machine learning system. While deploying Android Studio and the Java programming language,
the TERBISA application usability level is carried out according to the following work diagram. Includes functional suitability using black box testing, usability which is divided into effectiveness using the system usability scale and use questionnaire, as well as satisfaction with a Likert scale and questionnaire on the impact of using a sign language translator application on the interaction with deaf and mute groups. Also, performance efficiency was tested manually using 3 different Android devices and test response type. This research succeeded in producing a visual image-based sign language interpreter application, which can be easily used by ordinary people and people with hearing impairments, who are not accustomed to using spoken language. The main page of TERBISA consists of one button that directs the user to do the translation. Once pressed, the user can point the camera toward the gesture to be translated. The translation results will appear at the top left of the frame, accompanied by a description of the various sign language. There is a minute description of frame, crop, inference type,
the black box text. TERBISA is declared to have a good level of functional accuracy regarded by the suitability between the expected result and the application component and the test result. Meanwhile, the function error table stated there were 0 error, and the solution of the error gap can be overcome by upgrading the Android system and closing TERBISA with the closed application procedure as shown in the table. The SUS system data.
The conclusion of this research are the TERBISA software is made in the form of an Android application through 3 stages of development. First, the stage of making a system or learning machine using the Python programming language and the TensorFlow, MediaPipe, OpenCV, and NumPy libraries. Second, the state of system training or learning machine that has been made through the creation and labeling of dataset on RoboFlow. And third, the application deployment stage using Android Studio, which also functions to provide an interface display. The workflow of the TERBISA application is to take image from image recorded in the camera to be transferred as objects, referred to as hands in the system, to then enter into the prediction process by matching object landmarks with the stored dataset. Later, this prediction will be displayed in the text as a translated result. The TERBISA application is categorized as very effective for use according to the scores obtained on various test methods. Namely, first, the system usability skill score is 87.65%, so it is categorized as acceptable, has a big grid scale, an excellent adjective rating, and is generally very effective. Second, the use questionnaire score is 81.4%, so it is categorized as very feasible and effective. Third, black box testing, which stages a perfect match between the expected results on the application component and the test result, and no errors are found. Fourth, manual performance efficiency test, which certifies that the TERBISA application has a perfect match between the expected results and the test results on 3 different Android devices. Fifth, as well as the response time test, which states an average success of 86% and a minimum time of 8 seconds to do the translation in the response time test. So, the TERBISA application can be used in people's daily life with a score of 79.1% or good in providing user satisfaction on the Likert questionnaire for ordinary people, as well as a score of 83.95% or very good on the TERBISA use questionnaire by the deaf and speech impaired groups, which was also processed using the Likert scale method. The recommendations of this research are a broader and more capable server is needed to provide support for the use of TensorFlow, so that it can accommodate more datasets, as well as make the translation process faster too. The TERBISA application needs development and improvement, especially the feature allowing users to make additions actively.
That is all we can say. Thank you for your attention.
We apologize if there are mistakes, both in pronunciation and delivery.